So for the next 4 or 5 minutes you'll be going through a recap of acids, bases and alkalis. First thing to look at is the pH scale. You should be familiar with this. You should realise that pH, this is the pH scale here. pH scale actually runs from, you can get negative pHs, but for IGCSE you need to appreciate it runs from 0 through to 14. At 7, absolutely at 7, it's neutral. Even a little bit above 7, 7.1, 7.01, it's going to be slightly alkaline. 6.9, 6.09, it's going to be slightly acidic. The more you go down to the left, the more acidic it becomes. The more you go to the right, the more the number increases, it becomes more alkaline. So over here we've got strong alkalis, weak acids, strong acids. So some examples of strong acids. Battery acid, the acid that you get in car batteries. Your stomach acid is a strong acid. And weak acids, some examples, stuff that's weakly acidic. Your saliva is weakly acidic. Acid rain is weakly acidic. And vinegar, dilute vinegar, is weakly acidic. Stuff that's neutral, usually just pure water. Weakly alkali, some examples of weakly alkaline substances. Something called milk of magnesia, which is a chemical that you take to relieve an upset stomach. Baking powder you use in cooking, and seawater, they're weakly alkaline. Strong alkalis around the home would be drain cleaner and bleach. We'll look at some examples of acids. The examples of acids that you'd find in the lab, you'll get hydrochloric acid, which has the formula HCl, sulfuric acid, which has the formula H2SO4, and nitric acid, which has the formula HNO3. And if you're not sure what a base is a substance which is able to neutralise an acid. We'll look at some examples now. Sodium hydroxide is an example of a base, as is potassium hydroxide, as is zinc hydroxide, ZnOH twice. And the last example I'm giving you is copper 2 oxide, CuO. Now, all of these are examples of bases, and they're examples of bases because they neutralise any acid. They turn the acid to pH 7 if you add the right amount. Some of these bases, in particular these two here, are bases which are soluble in water. So these two here are soluble in water, and because they're bases which are soluble in water, they get a special name. So bases which are soluble in water are called alkalis. Now this is a different version of the diagram we saw a few minutes ago. This diagram shows colours, and the colours are with the universal indicator. And so if you had a sample that was neutral and you added universal indicator to it, it would turn a green colour. If you had a sample that was weakly acidic, it would turn yellowy green. And if you had a sample that was strongly acidic, it would turn orange or maybe even red if it was really acidic. Similarly with alkalis, if you had a sample that was weakly alkaline and you had a universal indicator to it, it would turn green or blue. If it was strongly alkaline, it would turn blue or maybe even purple. So universal indicator is good at telling us how acidic something is and how alkaline something is. In addition, we've got a few other indicators. Phenolphthalein is another common indicator, and in alkaline, phenolphthalein is pink, and in acid it's colourless. You've probably come across litmus as an indicator, and in acid litmus is red, and in alkali litmus is blue. And another common indicator is methyl orange, which in acid is red, and in alkali it's orange or yellow. You should also realise what makes an acid acidic. What is it about an acid that makes it acidic? We'll have a look at the 3 common acids that we find in the lab first, and look at those individually. And with hydrochloric acid, the reaction when it's in water, and that's what the AQ stands for, produces H+ ions and Cl- ions. What's happened is your hydrochloric acid has dissociated it's split in half to produce H plus and Cl minus. Let's see what happens with sulfuric acid and with nitric acid. Again, it's got to be in solution in water if it's going to split up, if it's going to dissociate. And again, you should see that sulfuric acid, hydrochloric acid produced H plus and Cl minus. Sulfuric acid also produces H plus and SO4 2 minus. So again, what's happened is it's split down here, as hydrochloric acid did. Hydrochloric acid split down here to produce H plus and Cl minus. Sulfuric acid splits down here to produce 2 H pluses and SO4 minus 2. Let's have a look at what happens with nitric acid. Again, it's got to happen in water, AQ. And again, it splits down here to produce H plus, there it is, and NO3 minus, there it is. So the crucial part about what makes an acid is this bit here. Acids in water dissociate or split up to release hydrogen ions. There we go, acids dissociate, which means split into ions, to give away H plus ions. Let's do the same for bases. And we'll actually at this stage look at alkalis rather than bases. It makes it a little bit easier. So you'll recall that acids could only act as acids when they were in solution. It's the same with alkalis. They can only act as an alkali if they're in solution. So to do that, oops, it's got to be an aqueous solution. And when sodium hydroxide reacts, again, it splits into two down here and produces an A plus and OH minus. So sodium hydroxide, when it's in solution, produces Na plus and OH minus. Potassium hydroxide is very, very similar in solution. It splits down here to produce K plus and OH minus. So the crucial thing about alkalis is that when they're in water, they dissociate and they release OH minus ions. So alkalis dissociate in water and they release OH minus ions.